So Ved Prakash is a formal verification engineer at Intel. Uh, he's applying formal verification FPV on various IPs and SOCs at Intel. He has 4 years of experience purely in formal verification. And prior to join to Intel, he has worked at ASCII Technology, which is NVIDIA now, for almost 3 years. Working closely with various design teams in harnessing the effectiveness of formal methods and techniques for high quality functional sign-off. That's his vision. Okay, so let's welcome Ved.
Thanks, Girish, for the wonderful introduction. So the topic of my presentation is oil check of PCI with formal verification. So you must be wondering what oil is all about. But believe me, guys, this is not related to that oil about which the whole world is crying about. It's not related to the quarreling which is happening between Europe and India. Okay? And I know it was a lunchtime and everybody is full. Just bear with me for half an hour, then you guys can sleep. So, let me first thank my co-authors, Carlson Lim, Zufeng Li, Xinjiang Wang, Anshul Jain, and Achyuta Kiran Kumar for their valuable contribution. So, firstly, these are the contents about which I'm going to talk about in the upcoming slides. I will walk you through the introduction of the paper, then I'll explain briefly about formal verification, but my colleagues have already explained you too much about formal verification, so I'm briefly going to explain about it. Then PCI is the project on which we actually executed our methodology, and then explain why oil checking is important in data transportation block like PCI. So now let me explain what oil is and what oil actually stands for. So oil stands for ordering, verification of integrity of data, and liveness and performance validation. So we have devised methodologies across the verification of these, so I'll cover this during the methodology verification explanation. And then I'm going to end this presentation with our key findings in the form of bug summaries, results, and conclusions. I think Girish has already covered this slide. So the verification challenges of modern day IPs and SOCs have significantly increased because of increase in the complexity of the design. Among various pre-silicon verification technologies, formal has gained wider acceptance as a fast, reliable, and efficient mechanism to achieve design verification shift left. It has proved its mettle in finding issues in complex time interface interaction. So it can help us to avoid late-stage bug escape sprints. Though the industry seems to be embracing formal across breadth of designs, but its usage is still limited. And it is because of various issues and false notions that there is lack of expertise which is there. People are afraid about the design complexity, and false notions such as formal is non-reusable, you cannot use the same test bench again, and it's expensive because it consumes too much time and effort. But with the advancement and addition of new features in EDA tools and new methodologies which we come up, the applicability of formal can be applied in many more areas to gain maximum on the effort invested and time invested. It is important to identify the characteristics of areas with high formal applicability. This will not only help us in finding the blocks which are formal friendly, but also the portion of or functionalities of the block which can be verified with higher confidence. So this has, people have already covered too much about it. They have already talked that why dynamic simulation is not that good because it is dependent on test stimuli. You can only cover a few of the permutations because of test cases. One day if someone comes up with a new test case and voila, you find a new bug. And now you're afraid. Now the design team wants formal people to be there so that they can do exhaustive and breadth-wise analysis so that down the line, even in future, if someone claims that, okay, this design is bug-free, then it is bug-free. Not something because someone down the line did not write this particular test case. Okay? So, let me just briefly explain you what PCI is all about. Mostly people know about it. If you don't know, you can go through the PCI base specification. But here are some things which I would like to highlight so then the methodology which I'm going to explain down the line, you can understand it and correlate it with. So PCI is a high-speed I/O bus standard, replacing older PCI bus standards. So design implementing PCI needs to adhere to certain transaction ordering, and there are reasons behind it. Because we don't want deadlock conditions to be there. We want compatibility with ordering on legacy bus, and it is critical for meeting the producer-consumer model. Ensures the coherency and integrity of data transferred from requesters to completers. Here are a few ground rules which everyone has to obey if they are using PCI. So there's a strong ordering relationship between those transactions which have the same traffic class and same VC channel. There is no ordering relationship between those transactions which belong to different traffic assignments. And these ordering assignments apply equally to all the messages, like whether it be memory, IO, configuration. But while we are maintaining a strong ordering relationship between these transactions which are completely, which let's say they belong to producer-consumer model and they belong to same traffic class, but they are unrelated. So PCI has a thing for that. So they have a relaxed ordering attribute which helps us to order those transactions ahead of other transactions in the same traffic class. Just to overall summarize what relaxed ordering is all about. So relaxed ordering attribute in PCI allows reordering of transactions if they are unrelated to producer-consumer model. So this allows for a better overall performance. Consequently, in other circumstances, a transaction with its relaxed ordering attribute can be reordered ahead of other transactions. So this is a table. So this table you can find in the base specification. For example, I'm going to take column 2 and row D, and let's say there's a strict ordering rule. So the strict ordering rule says a completion request cannot bypass, okay, a posted request. But what if a relaxed ordering attribute is set? In that case, the table specifically says that it can bypass, it is permitted to bypass a posted request. So now why oil check? Okay, and why things are important when it comes to ordering, integrity, and liveness. So as I explained earlier, formal is more valuable if you are able to identify those functions which are very critical in nature. And any data transportation block like PCI requires 3 features to be verified and 3 features to hold properly if they are verifying it, like for a smooth flow of this data transportation block. So first thing is ordering between same type and different type of requests. So requiring not only a single level of ordering, but also multi-level of ordering. Integrity of data or all those meta informations which are flowing from the input interface, input transaction to the output transaction, liveness and safety of each request. But violation of any of these features not only causes the functional, because in this competitive market, people don't want things to be functionally correct. They also want to be like its speed, its performance should be at utmost. So violation of these can not only break down the functional, but it can also break down the performance aspect of it. So at the end, so there are 3 pillars, or I'll say 3 gears for the smooth flow of this truck which I'm showing to you, which I'm considering it to be PCI. First thing is ordering. The second thing is integrity of data. And the third thing is liveness and safety. Now why? Like coming to the first gear of my methodology, which is ordering. Like Bangaloreans are the right people to know why ordering is important. Okay, and you know, if one person overtakes it and then full traffic jam. So okay, and this is a GIF which shows that okay, you are standing in front of a ticket window and someone suddenly jumps out and okay, I want the ticket. Then things are going to get violated. People are going to shout at you. Okay. So usually there are 3 types of PCI transactions flow. One is posted, non-posted, and completion. And for the simplicity and so that I can relate more with the examples down the line in the upcoming slides, I'm going to take the ordering relationship between posted and completion request. So a completion request cannot go before outstanding posted request and any outstanding completion request ahead of it. But a completion request which comes with an RO attribute set, they can bypass it. Okay, they have the flexibility with it. They are the VIP people. Okay, so in order to verify this behavior, we came up with a pseudo-random variable approach, where the first component is your floating pulse, which can be used to tag a specific request which you want exactly to verify. Okay, and it is randomly chosen. And the second component is a counter, which is used to track the number of requests received before this tracked request. Sorry. Okay. So let me explain you what floating pulse is all about. A pseudo-random variable asserted only once throughout the trace of a waveform used to randomly tag a request, and all the associated behavior with this transaction is actually verified. And on the right hand side, you can find the pseudocode of the pseudo-random variable, how to create that pseudo-random variable, which will be asserted only once throughout the trace. And the second component which I talked about is the counter, which was actually used to store the pending request. So now this counter will be incremented for every put, for every incoming transaction, and decrement for every outgoing transaction until the pulse request is received. But as soon as the pulse request is received, you stop. Your counter will only be decremented on get, nothing on the put. And you can see the working of the counter on the left side again. Okay. So let me take a simple example over here to explain how the pseudo-random variable approach works. Let's say in your IP there are 3 requests, type A, type B, type C. And there are relationships happening between these type A, type B, type C requests. We are going to verify 2 requests at a time. Same can be applied for type A, type C, type B, type C, but let me take type A and type B. Okay. So a separate counter needs to be maintained for both of these type A and type B. So we are going to create 2 counters, 2 pending counters. Okay. And now considering the strict ordering case, so if a counter value of B is 0 and tag B request has gone out, that means the counter value of B being 0 means your tagged request is eligible to go out, and this is getting signaled by the get or whatever signal, qualifier signal you have on the output interface that tells you, okay, now this request which was tagged is eligible to go out. Now, if we are writing this, then based on the strict ordering, the counter value of A should also be 0. So just to summarize, I'll repeat myself again. If counter value of B is 0 and tag B request has gone out, then counter value of A should be 0 as per the strict ordering case. Now let me take the second case of relaxed ordering, where your type B request is allowed. It has its RO bit set and it is allowed to bypass it. Okay. So if counter value of B is 0 and counter value of A is non-zero, that is there are still outstanding A requests which are still sitting in your queue or still sitting inside your system. So, and get of tag B request is high, then RO signal should have been set of the tag B request. Now you will be wondering that what is this RO signal and how you're saying that it should have been. So as soon as incoming transaction comes and that transaction you have chosen using Pulse, you store this information in a form of flag. Okay, this for this particular tag request there was RO which was there. Okay, and when you're writing this property, you're making sure that okay, if my tag request is actually going out and there are pending values in my another type A request or another request, then my RO signal should have been received when this incoming transaction actually came into the picture. So what is data integrity, the second gear of this system? So data integrity means that all the information which came with this incoming transaction, it stays put and same information is passed out of the block. Now people consider verifying data integrity to be complex task, especially from the coverage point of view. But there are existing methodologies in the industry. Like for example, you can create a FIFO to store the data and to ensure the ordering and data integrity. Now the pseudo-random variable approach which I talked about, it can not only be used to check where your ordering, your single level of ordering or multi-level of ordering, but it can also be used to verify your data integrity. And the third one is data coloring approach, where you can like constrain few bits of the data and then say that if, since this was the only data which was present at the input, the same data should go out, nothing should change. But I'll say all these methods are costly because they are complex. It requires you to model, debug. Okay. So, but with the, as I mentioned that EDA tools are also catching up. So there are features in the EDA tools which can be exploited in this case, and which I'll say is formal scoreboard. And I'll term it to be the winner among all this. And I explain why I'm terming it to be the winner. So as the verification challenges increased, EDA tools kept on upgrading the features. And now formal scoreboard can catch data corruption issues in designs with minimal checker development. It can be used to prove data integrity, dropping or duplication of data, and ordering between same type of requests. And now most of the leading FPV apps comes with formal scoreboard, which provides almost all the above mentioned functionalities. And So what happens in formal scoreboard, all the data and attributes of the same transaction type or the incoming transaction types, which uniquely identifies itself, are fed into the scoreboard, and all the attributes which are going at the output interface are also fed into the scoreboard. And now the scoreboard is a part and parcel of the FPV apps, and they will be doing in the data integrity check. And this picture shows the illustration of how formal scoreboard actually works. And as I mentioned, like you can assume, basically, since it is a part of and parcel of the formal tools, I cannot tell what they are actually coding it, but somewhere down the line in your back of your memory, you can assume that maybe they are creating a FIFO and they are ensuring the data integrity. I totally don't know what they are doing, but yeah, if you are creating your own pseudocode to verify data integrity, I can say that you are using either the pseudo random variable approach or FIFO method. So, but while we were exploring through the formal scoreboard, there was one feature which we uniquely identified. That was data selection feature, where the scoreboard itself notified which incoming transaction it is selected, and when the same incoming selected transaction was going out, it was notifying that, okay, this is the outgoing selected signal. Now, this feature can be used to do start of the packet and end of the packet checks, but we thought maybe we can use it to verify some simple data transformation behavior. So let me take an example over in this case, a simple design requirement. Let's say the incoming transaction is coming and it is already poisoned. Now, if it is already poisoned and it is going out, the same information should traverse. Nothing should change. That this incoming transaction is poisoned, and it should also be poisoned when it is going out. But vice versa can happen, that the incoming transaction is not poisoned, but while it is leaving out, it is poisoned. Okay, so since I told that the scoreboard itself, it's notifying that it's the incoming selected and outgoing selected, which transaction it has actually chosen. Now, as soon as incoming selected happens, you flop that information with whether it was poisoned or not in a poison data flag. And you can write a simple properties, two simple properties, that if the outgoing selected signal is high and the poison data is set, okay, your flag was saying that the incoming transaction was already poisoned, then poison out signal should also be high. And similarly, you can write the second property that outgoing signal, a selected signal is high and poison out is not set, then poison data should also be not high. Now, why I was saying that formal scoreboard is actually a winner? Because very little effort is needed to set up the scoreboard. Modeling failure, debug iterations are not required. It reduces your modeling effort for checking ordering requirements between same type of transaction. Why? Again, I'm saying that same type of transactions, because PCI requires multi-level of, there are multiple transactions and multi-level of ordering is there, but between same type of transactions, you can verify data integrity and ordering as well. And we actually find out that compared to the manually created code, which was there, like FIFO, in some of the EDA tools, actually their scoreboard was pretty much faster compared to the manually created one. So that's why it's a winner. So, and data selection feature, which I talked about, if it is present in the formal scoreboard, because it depends on tools to tools, which EDA tool you are actually using. If it is present in your particular EDA tool, then you can explore this feature, and it can help you to write simple data transformation checks. And other properties can also be verified, like if there is a data chunk splitting which is happening and merging at the output interface is happening, you can verify it. But if, just a disclaimer, if the feature is supported in the EDA tool. So last two ones are the ones exclusive to some EDA tools. Now jumping to the third gear, liveness and performance. So just tell me guys, will there be any data integrity violation or ordering violation if your transaction is actually not going out? I believe no. Because you check anything, when the first two things which I mentioned about data integrity or ordering, when your transaction is actually leaving out. So now you are thinking, okay, liveness property is already there. You can just write a liveness property that within eventually or within infinite number of cycles, the transaction can go out. But when it comes to PCI, there's a feature, RO, relax ordering. And that feature is not unnecessarily sitting there. We want the things to happen within finite number of cycles. Otherwise, the purpose of RO does not make any sense. So to ensure both the functionality and performance aspect, we require a safety property. Now the safety property checks the liveness by ensuring that the request goes out within finite number of cycles. So now when it comes to writing a safety property, again, I didn't rename it to be a specific approach, but you can call it as a safety property approach. So this approach consists of a counter. It has three factors. The first factor is start, when your counter actually has to trigger. Stall, when it needs to be freezes, like when, let's say, there's any kind of external dependency happening, when it needs to freeze, and the finish conditions. The maximum number of cycles within which this transaction has to go out, it has to be calculated based on the specifications, based on the microarchitecture, not based on the implementation of the designer. Okay, so this tells us how you can create those pending, how to create that counter which actually triggers on the start condition, which freezes and which finishes. At the finish condition, you have to reset your counter at any specific value, which, you know, for here, for it's better to reset at 0. And we can write two properties. The first property is assertion, okay, which says your counter should not overflow beyond max count. And the second property, which is the cover property, is, I'll say it is much more important than the cover, than the assertion property. Because sometimes it could so happen that maybe by any chance, there's something in your design which is actually not causing the start condition to happen. So you can write this cover property and say, okay, whether your start condition is actually hitting. If your start condition is hitting, then yep, your counter is going to work. Otherwise, the counter is going to give you a vacuous pass. That assertion will pass, and you will not know whether your counter is actually ticking or not. So let me explain the key findings over here. Like, when we took this project, okay, so dynamic simulation was already done. It was over a year, but one random guy suddenly changed the test case, and voila, a bug popped up. Now the design people were in a haste, like helter-skelter, what to do now? So they called us. They told formal people, can you verify, can you see that ordering violation is not happening? And there is a bug related to ordering. Okay, and we told them, okay, don't tell us what the bug is all about. Okay, we'll write a checker, we'll write an exhaustive checker to tell whether the ordering violation is happening or not, and whether the fix you applied is correct or not. Okay, so we wrote as an assertion based on the pseudo-random variable approach. Let me explain you what the bug is all about. The bug seems to be very trivial in nature, but it took in a year for dynamic simulation people to find it out. So first, a posted request is received, followed by back-to-back completion request. The first completion request has relaxed ordering set. That is, it can bypass the posted request. But the second request, it is not relaxed order. It should not bypass the posted request at any cost. But it was happening. It was bypassing the posted request. We used the pseudo-random variable approach. We wrote the two assertions which I talked about. The first assertion was if the pending counter related to completion is 0 and the completion request, my tag completion request is going out and the RO is not set. Okay. Then the pending transaction of posted request should also be 0. This will verify the strict ordering case. Now the second case, relaxed ordering. In that case, we are saying that my tagged request is going out. That is, pending counter related to completion is 0. My completion request is going out. But the pending counter of posted is non-zero. It means that RO should have been set. We have created this RO set as a flag. Now, while we were verifying this ordering problem, there was an interesting thing which happened. So I was telling about like this antecedents which we actually wrote in order to verify the ordering case. One of the antecedents did not hit. And we are wondering why it is not hitting. So we thought of writing this forward progress check. This the safety property approach we talked about. And what was happening is while they fixed this particular bug, they entirely stopped relaxed ordering. And now, since you're stopping relaxed ordering, you want to be competitive in the market, but your performance is gone because you entirely skipped something. So this bug caused RO set completion request to wait for posted request to get cleared out first before it can go out. It can go out, but it was not going out. It was stopped. So just let me explain the scenarios briefly over here. Posted request followed by a completion request, and completion request has a relaxed ordering attribute set. Now we use the safety property approach. We wrote the start condition. The start condition was first we received a completion request and we tagged it by pulse. Now second thing is stall. The stall says that until my count C is 0. Count C means all the outstanding transactions which were ahead of it, of my completion request, they have gone out. And now the finish condition says if my counter value is 0 and my completion request has gone out or not. This is my finish condition. So as per the interaction with the designers we had and as per the specification we found out, if there is nothing in the design which is stalling my completion request to go out, my relaxed ordering completion request to go out. It should go out within 2 cycles. So the max value of counter was 2. So, so these are the key results which we're able to find out when we did the entire project. So this project was already verified, okay, but still we checked those critical functionalities about which the designers were worried about. They were worried about ordering. They came to us. We told them, now since we have written this assertion, we can truly see that you do not have an ordering problem. Because when we wrote that assertion, when we reproduced the bug, okay, it took like 10 seconds to fail that checker. 10 seconds, which was for simulation, which was very, very long. For formal, it was just 10 seconds. Okay, and total 8 issues we covered. The design was already signed off, but still after that, we were able to find 8 issues. We gained the confidence that ordering is not violated in this ordering critical module, and FP reproduced simulation resistant connect bug through ordering check within a minute of time. So you must be wondering that since it is formal, I talked about in the start itself, design complexity, people say, okay, why to apply formal? There are already too many queues, sequential blocks, which are then how to verify it, how you converge on that. So this was the largest project size, 69K registers, 6.2 million gates. But after the abstraction, we reduced it to 3K registers, 66 gates. Okay, and this helped us to converge our properties. So let me give you the effort estimate which took in order to create the setup. It took us 2 weeks to fully understand what PCI is all about, what transaction ordering is, what posted, non-posted completion. It was my first time, so it took me some time to understand it. And then, but overall effort, it took me 4 years. Once I understood, okay, what this design is all about, so what kind of properties I need to write to ensure that ordering liveness is happening properly and data integrity is happening properly. So exhaustiveness, in order to ensure exhaustiveness, whether our property is correct or not, we kind of challenge the designer. Okay, like we wrote the property, our property was not converging, okay, but it was way past the RPD which we calculated. We told the designer, tell us the functional cover, tell us the any remote corner case which you want us to verify. We'll write that functional cover and we'll make sure that that functional cover is hitting before the bound which our assertion is able to reach. So let's say our assertion was reaching the bound of 16. Any corner case functional cover which he asked us to write, it was able to hit at 5 or 6. We did manual code reviews with the designer. We verified the constraints which we have written in the simulation. And in the entire process, we used SV properties. Okay, we wrote our assertions through SV construct and we used SVAs. I already mentioned about the abstractions, which we used in order to reduce the gate count and the register count. We used queue size reduction, parameter value reduction, and etc. There were other abstraction techniques we used to reduce the number of registers. And the entire property was run for 24 hours to complete with 92% of proven checkers and 8% of bounded pass, with full confidence that we have bypassed the required proof depth which is required. For this entire verification work, this is something for your information. Maybe with more jobs, you can converge it at a faster pace. We use 20 GB memory usage for each job and 4 jobs were used. So let me just conclude. We showed the effectiveness of our proposed solution. We were able to find the very much difficult and simulation resistant bug. Okay, we found new bugs. And we recommend using these FPV techniques to solve ordering, data integrity, and performance related issues, not only in PCI, but other data transportation blocks as well. Because this can be exploited. This can be exploited in other blocks as well. So with the future scope, I'll just say, because people remember us only at the end of the project when they're actually troubled, when they have utilized all their weapons in the arsenal, then they call the FP people if they are in the trouble. I'll say to start FP right at the start, when they're actually coding the design, when they're actually making the design, call us as early as possible so it does not affect your tape out. It does not cause any kind of respin. So the activities which we did, it motivated the various design teams to leverage FP in other critical areas. We are using our technique in other areas as well. And we are talking with other design teams to start the formal verification as early as possible in the development stage itself. Okay, with this, any questions?
Thanks, Ved. Questions for Ved?
Either I was too clear or either people did not follow it. I'll take the first one. Okay.
Okay.
Or the food was too good, I think.
Yeah, we have one question.
With you had both liveliness and safety properties, right?
No, I use the safety property. Because liveness is something which I'm saying that you can write liveness property. Usually people write liveness property, but you have something in your design which says, which wants performance to be there. I'll suggest safety property because safety is something which I'll say is a superset of your liveness property.
Right. And second question would be, you talked about the formal scoreboard, right?
Yes.
So it was giving better results, right?
Come again.
It was giving better results as compared to your own model.
Yes. We found that information that like
Were the properties converging or?
No. The properties were not converging, but let's say in 6 hours, let's say my property with the model which I created, it was able to reach 22. With the formal scoreboard, it was able to reach in the same time to 24, 25. So I'll say better conversion.
But let's say like 25 is not enough, right? I want to reach to 40 or something. Can I play with the formal scoreboard to reach to that depth? Is it easier, or my model would have been more easier for me because I know I have modeled it?
Yes, formal scoreboard is something because
Let me put it more explicitly. Was it encrypted or you could see the code?
I cannot see the code. So
Okay.
that's why I told that I will, in any case, I'll start with pseudo random variable approach. But
Okay.
formal scoreboard is the one which, like, if you don't want to do the coding, but abstraction is the thing. Abstraction is the thing which can help you. So even if I am doing my modeling, or even if I am doing the scoreboard, since both of them are not converging, and let's say your bounded proof depth is way beyond whether they are reaching, abstraction is the thing which you have to go for. Either you need to cut point the signal, either you need to black box it. If you can reduce the parameter, you reduce it.
And can we dump the complexity report of formal scoreboard?
I don't think so. Maybe the
Got
EDA tool vendors can tell more about that.
Thank you, Vai.
Thanks.
Thanks guys for bearing with me. Now you can sleep. I'm just kidding.
May I request with Shobana to present the certificate? They all can come. Please.